Okay, so if we're graphing this with the transformations, the first step is to graph the this y equals just log of x base 3. That's our base function, right? So you guys are asking about that. Well, remember this is x equals 3 to the y, or the inverse of y equals 3 to the x. So it's the inverse. Now you don't have to draw this one necessarily and then flip it, but you could. You could draw this exponential, which you know a little bit more about, and then flip it around the y equals x. That's what we took a look at in 8.1. And then this is the graph right here. But you can just go here and make a table of values. You can go back to here, make a table of values real quick, which looks like x, y. Okay, and this is what you'd have to do. So if x is if x is, well, where do you want to start? X is 1. So 3 to the power of what gives you 1? 0, right? 3 to the power of 0. Okay. So if x is, now we're going to go up to 9 now. Why 9? Why put 9 here? Because 3 to the power, 3 to the, no, let's do that too. Oh, that's the y. 9 is here. So 3 to the power of what gives us 9? 3 to the power of 2, right? So 27 is 3 to the power of 3. Okay? So you could start with a table of values here with the log. If you haven't had a lot of practice with that, then you'll have to you'll have to practice with that, right? Put in, you can put in a 1 here, and then a 2 here, and then a 3 here, and so on. Those would be the y values. So I did 0, 2, 3. I could do 1, 2. 3 to the power of 1 is just 3. Okay? All right. So this graph right here, this is going to be 1, 0. That's 1, 0. That's this point. I'll do it in yellow. 9, 2. So you go all the way over to 9, and then you go up 2 units. If you were to go over to 27, you'd have to go way off the chart here, 27, and that would be up to 3. So this is sort of, roughly your sketch right here. And then we haven't done any between 0 and 1, but I suppose we could. If, let's say 1 over 3. So if x is 1 over 3 right here, that's 3 to the power of what? 3 to the power of what gives us 1/3?
-1.
Yeah, -1. So then x of 1/3 goes down to -1. Okay, so it's maybe easiest to think of the exponential situation in graphing this, but this is what it would be. This is just the flip of the exponential one, right? Because this is 1, 0. This is 0, 1 for the exponential one. This is y equals 3 to the power of x, right? So this is 1/3 -1, or -1 1/3. You see, everything, it's just flipped. So graphing that, all you need is a few points there, really. Like this one, and this one would be enough to kind of start a sketch. Then from there, once you've got y equals log of x base 3, once you've got that, then you go ahead and look at the transformations. We always start with the a first, and then you move on to the b, then you move on to the h here, and then the k, right? So you move left to right. So let's see if we can do this. It's going to be a little tricky on the without lined paper, but the negative, what does the negative in front do on a situation? It flips it which? Vertically or horizontally? Which way? Yeah, vertically. So this one stays the same, right? So let's do this in red. So this one stays the same. This 1/3 -1 becomes 1/3 +1. This 9, 3 becomes 9, -3, and so on. So now we have this as our first sort of stage of the transformation. It's just flipped vertically. Okay, check, got that. Now the b value is just 1, so it does not squish up or expand. Remember, the horizontal stretch or compression is 1 over b. It's not negative, it's just 1, so it doesn't squish or flip this way at all. Now it moves which way? 1 unit? 1 unit to the left, right? So this is the horizontal shift in here. Anything added or subtracted to x is a horizontal shift. Because it's a plus in here, then that's to the left. So this red graph now, let me draw, oh, what color? Let me pick another color. Let's pick light green. So it's going to go 1 unit to the left. So this is now going to be the 0, 0 here. Okay, so it's going to go 1 unit to the left, all of these. Okay. And then finally up 2. So the final one will be in the color of pink. Okay, pink. So up 2. So this point right here, you go up 1, 2. So it's up here. Okay, and this pink one should be your final resting place here for that. Kind of looks like that. Okay, so just start left to right, apply transformations just like we did for all of our other ones. But yeah, if you're having trouble getting going with the log there, you start with this, start with the base function, do a table of values, sketch it, and then go from there. That's probably the easiest way to do that. All right. Okay, I do want to go over, where was it? Somewhere. This one right here. I want to go over this one right here, just so we can identify the transformations just from a graph. So determining equations of a log function. That's kind of important to make sure we know how to do. So let's just take a moment and take a look at this one. So if the blue graph here is y equals log of x, and obviously there's no base, so that's understood to be a base of 10. If you have 2 points that are listed on these 2 graphs, then you want to focus on those 2 points. So here's a blue point here, here's a red point here. So that there's 2 options for this. Is this graph moved up without changing shape, or is it stretched up? Because obviously these are in a vertical relation to each other. So is it this? Does this look like a stretch, or does it look like a translation up? Okay, I heard both. Let's take a look at graph. Let's take a look at a different graph. And then look at this graph 3. Does that look like a stretch up or a translation, a move up? This is a straight move up. With this one, notice how, do you see this blue graph? This moved up to the red, but then this one moved down to the red. See? So that is a pulling, a stretching, a vertical stretch. So yeah, so what you want to do then is focus on these y values. This is 1 here, and this is 3 here. So it appears that something times, or 1 times something gives us 3. So this is an a value of positive 3. So if this was half, then this would be to go to 1.5, right? Which is about true. 0 stays at 0. Negative half should go down to negative 1, which is about negative 1.5. Should go to negative 3 or whatever. Anyways, forget about that. Can't really see it anyways. Okay, so that's a equals 3. So this is, the red graph is y equals 3 log x. You want to see that? Okay, now what this is doing here, this is actually, we're mapping stages. So now this is, the red graph is now translated down here. Okay, and now it goes to the green graph. So look at what's happening here. We have a red point there and we have a green point here. So this has it compressed or has it moved? Which one do you think? Compressed. Yeah, because there's a different distance between the graphs here. You see, they get closer and closer here. So that means it's a horizontal stretch. So this has come back from 10. Now it goes to 5. This one is 4, and this one straight across is exactly 2. This is 2 to 1. This is 1 to 1/2. So it's coming back. It's a half, right? So that means that 1 over 2 is our horizontal factor. So what is the b value? 2. The b value is 2 then. Yeah. So for this green graph, going from the original y equals log of x, this green graph is, we have this 3 here from before, and this will be log of 2x. So I've done two transitions, times 2, and then like times 1 over 2 for horizontal. How does that feel? Any questions on that one? Okay, let's keep moving on. So now that we have the green graph here, the green graph, or no, what is that color? I guess it's kind of like tealy green. So tealy green, now this tealy green graph right here is going to move to this purple graph. So what's happening to that the green graph to get the purple graph there? Okay, this looks like a translation up. It's the same distance between vertical points. Okay, it's different than a stretch. It's the same distance between vertical points. So it's gone up a value of what? Is it 1? I guess. It's pretty close. Which are the points that were given? Oh yeah, the points were given there from 3 to 4. Yeah. I'm looking over here and they don't look exactly like 1. But yeah, these ones are 1. So where is that going to go? Is that going to go inside with the x, or is that going to go outside? The vertical translations are outside. So this purple graph, which that's definitely not purple, but I don't have purple color. Let's just go back to blue. So it's y equals, we got 3, we got log 2x, and then outside of that is plus 1. Might be a good idea to show some brackets there, just so you don't get confused. Okay, finally, what is this translation? The purple graph to the orange graph, it looks like it's going, and notice here that the asymptote has moved. That's a huge hint. The asymptote has moved 4 units to the right, so that's a translation for sure. A stretch wouldn't move the horizontal or the vertical asymptote, right? A stretch doesn't. So only a horizontal translation does. So this is plus 4. Now it's going to show up as a minus 4, and actually we have to be super careful because I need to be really careful about what happens inside here. So b is 2, but only when it's factored out can I put my b in there, or my h in there. So now this has to be a minus 4. All right, that's a bit tricky, so let me just go over that one more time. Remember with our transformations, it's a log b to the x minus h, and then plus k. I think it's h and k still for you guys. So if I have a 2 here, that 2 has to be the b. This number is the h only if it's in a factored form like this. So that's why I had to put the brackets there. If I didn't want brackets there, you don't have to write it like that. You could write it like this, 2x, but then this has to be minus 8. And you have to just be careful there, okay? Wherever you want to put brackets there. So these are both the same. Any questions about that? Okay, so that's a quick one on sketching and determining the graph. Clear? Fairly clear? Clear as mud? All right. Clear as mud, it's an expression. It's like sarcasm. It's like, clear as mud. Mud is not clear, so it's like, yeah, it's clear as mud. That means it's not clear.